Hello everyone and welcome to my channel. So in today's class we have this question which says that the possible terms arising from a P1D1 configuration are. Okay, so we have been given an electronic configuration and we have to find out the suitable term symbols for this electronic configuration. So first of all, what we should do, what should be the first step? We have to understand the term symbols that will result from this P1D1 configuration is a combination of these two electronic configurations. Okay, so combination means, so first of all we have to write the P1 configuration and then we have to consider the D1 configuration. So both P and D contain one electron each, so 1. Okay, now for P1, what should be the L value, that is the individual orbital angular momentum or the azimuthal quantum numbers. So L1, let us suppose for P1 the L1 is, so since it's a P orbital, the L value is 1. Okay. Similarly, D also contains one electron. And now let us suppose if the azimuthal quantum number for D1 is L2, then for D orbital, what is the L value? What is the orbital angular momentum value? So that is 2. Okay. Now the total orbital angular momentum, that is denoted by L. Capital L indicates the total orbital angular momentum. Okay. And this total orbital angular momentum is the summation of the individual orbital angular momentum. So we have L1 and L2 as individual orbital angular momentums, and the summation of these two, L1 and L2, gives the total orbital angular momentum, that is indicated by capital L. Okay, so now L1 plus L2 becomes 1 plus 2, that is 3. And we know very well, while writing a ground state term, we take the base term as L, capital L. That is the total orbital angular momentum is the base term. And this base term is indicated by different term symbols according to the value of L. Okay, this capital L. So if L is 0, then the term symbol is S. If L is 1, the term symbol is P. If L is 2, the term symbol is D. And if L is 3, the term symbol is F, like this. And this you know already, that the capital L, total orbital angular momentum, is assigned different term symbols according to its value. So now we can see here that we have capital L equal to 3, that is the total orbital angular momentum is 3, and the corresponding base term which corresponds to 3 is F. Okay, so we have got this base term, okay, ground state term, that is F. So out of these, we have all the 4 options have F. Okay. Now, we know that in this term symbol, the superscript, what is the superscript? That is the 2s plus 1. And what is 2s plus 1? That is the multiplicity. Okay. So, our next step will be to calculate the spin multiplicity. Now, for that, we need the individual spins of P1 and D1. Okay. So what should be the individual spin of P1 and D1? P1 and D1 both contain one electron each. Okay. So let us say the spin corresponding to P1, individual spin, let us say we designate it as S1. So S1. Okay. So S1, we know that for a single electron, the spin value is half. It could be plus half or minus half. So let us suppose we have plus half. Okay. And similarly for D1, we have the individual spin S2 as another plus half. Okay. Now, in order to get the total spin, again what we have to do, total spin is S1, the summation of individual spins. Okay. S1 plus S2. Okay. So half plus half, that becomes 1. So the total spin is 1. And from here, from this total spin, we have to calculate the spin multiplicity. And we already know spin multiplicity is 2s plus 1. So 2 into 1 plus 1, that is 3. So the spin multiplicity comes out to be 3. So in this question, we can see one more important thing, that the value of J is not being given or asked. So we do not have to bother about the value of J, which is the spin and orbital angular momentum. Okay, so we have been given only the term symbol, the base term and the multiplicity. So we have got both here. So we have got the term symbol F and the multiplicity of 3, which will be the superscript. So F3. Okay, one possibility. So where we have F3, we have F3 in options 2, 3 and 4. Okay, let us see. And with that, we have few options of 1F, 1D and 3D. Okay, let's check. What could be the other possible option for the P1D1 configuration? Now, after knowing that we have one possible term symbol, that is 3F. So, what other possibility exists? So this L value, that is the total orbital angular momentum, this cannot change. Okay, then the multiplicity depends on the individual spin value. Okay, and the spin can have either plus half or minus half. So out of L and S, that is the orbital angular momentum and the spin angular momentum, what all things can change? Only the spin value, the individual spin can change. So we have taken in the first case for F3, we have taken both the spins as plus half. And there is also a possibility that one of the spins could be minus half. So electron has that freedom, it can orient like this also. Okay, that is the spin can be anti-parallel or spin down position also. And if it is one is spin up or parallel, then it will have plus half value, and if in the other configuration any other. So if this electron has a spin down configuration or anti-parallel, then the value will be minus half. Okay, and the total spin becomes plus half minus half, that becomes 0. Okay, this anti-parallel orientation can be possible for either P1 or D1. If one is parallel, another is anti-parallel. So this possibility exists. Now, from this possibility with a total spin value of 0, so if total spin value is 0, then the multiplicity becomes what? It becomes 1. The multiplicity becomes 1. The base term remains the same because the L value is same for P1 and D1. Okay, capital L value, orbital angular momentum. Only the individual spin value can change. And from there, the multiplicity also can change to 1 instead of 3. So plus half gave us the multiplicity of 3. While plus half and minus half will give us the multiplicity of 1. So multiplicity is the superscript, and then we can have the ground state term symbol as 1F. So now let's check the options in the question. So we have with 3F we have 3D, with 3F we have 1D, and with 3F we have 1F. So 1F is the only possibility which can exist for the P1D1 configuration. Rest others 3D, 1D, it cannot exist. Why? Because for D base term, that is if the term symbol is D, that is the base term is D, then the L value has to change. It cannot be 3. For P1 D1 configuration, the L value is 3 and the corresponding base term is F. It cannot be D for the P1 D1 configuration. So we have the fourth option, which is our correct option. So I hope this explanation is clear to you. And if you have any questions, any doubts, please write it in the comment box. And please let me know what you want to learn next in chemistry. And also do not forget to like, share and subscribe. And thank you so much. See you soon.